Now I'm in the garden to do the unit testing of my valves. I got a ball valve. Actually, it is rated to PN63. It would be even holding 63 bars. I will let 1 bar on it, but it's on the safe side. I have my new silicone hose, which I will try to pinch and release to see if that's a good way to do it. The goal in the end is to get as much beer into this glass and as little foam as possible. As adding foam is easy, removing is impossible. This is my improvised beer keg. Again, one of these sprayer bottle for the garden, but I took this straight from the store, so it never had any chemicals in it. So first step will be to fill that with beer out of cans, because that's the only beer I have. Hook up the CO2 I have down here and run some tests. So let's do a first test with 4 cans, therefore 2 liters of beer. A tricky thing is how to fill that thing without making too much foam, because I want the foam to stay in the beer to make a more valid test. And the big advantage of being in the garden, and that's the reason why I'm here, if I drop beer on the floor, it's fertilizer for the garden, but I won't have to clean it up afterwards. And it's not gonna smell like beer where I live. First can of cold beer, slowly into this. 1, 2. Actually, I got this recommendation from the guys I went to, the friends with their microbrewery. They were like, find some kind of keg you can fill with some cheap beer to run more tests. He recommended me to get there are beer kegs that you can open up and fill manually. I was like, nah, too expensive. I go for this plastic bottle here, which I think is a viable alternative, at least to run tests. So, here we go. 2 liters of beer. Now, close the lid with the riser tube. So, and now, what am I gonna hook up? I start with just the hose, test the hose pinch valve approach, but with the thin hose, tighten this thing around so it doesn't pop off when the pressure comes. I need to twist the hose in one direction first, and then I can screw that thing on without twisting the hose, because I'm untwisting it again. That is the fill tube that comes from my machine, which I want to reuse. Oh, what is bloody here? I know how I cut myself. Basically, this is the same setup as I have in my machine, except that it's not closed, it's open. So let's pinch that one, simulate the pinch valve, add some gas here, open up this one. Beer starts coming into the hose, I see. And as you can see here in the hose, we have some bubbles going around, we have some liquid, we have half purged the hose, so let me try to let out some gas. Now if I run it with a slight pinch thing, you see how here it's clear and here it's foamy, and I have only foam coming out. That is the issue I think I had before. But now if I go down here and I open up completely, why do I generate so much foam? We have a shitload of foam here. Let's try another time. So if I come in here, where is that foam coming from? Not the outcome I wanted. So is it just this little connection here that generates enough turbulence to make my beer foam? I don't know yet. Let's have a beer first. So, ready for the next round. Keg is filled. We'll probably have a few drunken ants in the garden tonight. So, now just the tube. To figure out if just the tube works, we pinch it about here, send in some air, so everything is pressurized. Let's purge off the liquid out of the tube, the air out of the tube, somehow just have it think that's it. So now down in here, open up. It flows way too fast. It's just the flow that generates the foam already. See that? Not good at all. Way too much foam still. So as soon as it starts flowing, let me test that. But a pressure regulator also does strange things. But yeah, it does. So how am I supposed to further reduce the flow? Because I think it's just the velocity that's too high. Let's try to reduce the pressure. Thing is, now I'm at a pressure where my manometer gives 0. Look, that's the pressure I have. I have absolutely no feedback what pressure is going to the keg. But worth another try. Gently filling that stuff into the keg. Screw on the cap. That one goes. That one goes to that tree. Next, try with much lower pressure. Let's see if that helps. So first, close that one off. Open that one up. Pressure builds up. Purge first. The whole tube here is very clear, so no foam. Now let's try again with what I think is about the lowest possible pressure can get in. Wow, it still comes in very quickly. But, I mean, at least it's more or less clear liquid, right? That is about what I'm trying to do here. Let's try a second one. Yeah, another mess. Still flowing very quickly. Try to reduce the pressure even more. Try to find the absolute minimum I can send into. Now something is crying. At least it's sunny, so drinking beer matches the weather. But in order to stay scientific, this beer goes away too. Let's get a few other cans. With the really lowest possible pressure I can achieve, I'll try that again. Purge off the air of the tube. I already have foam in the tube, because here is the liquid coming. So now we're purged. Now again. That's about the speed I want, the amount of foam I want. That's good. And since we are pretty slow, I don't have the turbulence that might cause trouble. Now, does this tube cause turbulence? That causes foam. That's the important question now. If it does, it means that I have to rethink my whole approach. So let's try again. No, it doesn't. That's about what I want. Try to finish that one. Oh, it is finished. Of course, if you send CO2 through the beer, that generates a lot of bubbles. That was to be expected. I saw a beautiful animal flying around. Now, foam cannon. What? I need a more precise manometer. That could help to really measure the pressure I have right now. Let's try that. But nevertheless, with the lowest possible pressure, we are getting somewhere. So I found my sweet spot now. It is 0.5 bar. Half a bar is about what I'm looking for. Let me test that. 50 kilopascal means 0.5 bar. The problem I have is if you look down here, see, the manometer on the pressure regulator is basically useless because it tells me that I'm below 0, even if I am at a half bar, 0.6 bar even. And these pressure regulators are not so easy to adjust for low pressures. But yeah, I have to work with that. So 0.5 bar is the sweet spot. So I will put everything back together and do end-to-end testing with 0.5 bar, and I hope this time it works.